Hi everybody, welcome back to my channel. You'll notice that normally I introduce this channel as a channel on Feynman integration, but I'm going to start doing some kind of random interesting problems I see from other online math YouTubers. This one is from the channel Maths 505. He solved it using a substitution. There is another way that, in my opinion, is a little nicer. It's slightly less messy. So we'll just get started. This is a nonlinear second-order differential equation, and we'll solve it like this. We'll rewrite this as y double prime over 1 plus y prime, and we'll set that equal to y prime over y prime over 1 minus y, and then we're going to factor out a negative sign to make this y minus 1 on the denominator. Because I always, when doing differential equations, I always like to have my variables or my functions be positive. So we're going to write it like that. All right. So now you'll see both sides of this equation are in the form 1 over u du. This is, if this was our u, this would be our du. In other words, the top is the derivative of the bottom. So we can integrate both sides of this very, very easily. And it's just, I'm assuming that y is a function of x. In fact, I'll write that. Y is a function of x. So yeah, integrating both sides of this is going to give you this. This is going to make this the natural log of 1 plus y prime is equal to negative natural log of y minus 1 plus c. Okay, and now, in fact, I'm going to bring this negative sign inside the natural log and flip it. So this will be natural log of 1 over y minus 1. Okay, well, since this is true, then this is also true. Okay, so now we can cancel, well, actually, you know what, I'm going to label this C1. And then we'll use, we'll use the e to cancel the natural logs, but we will also have this constant factor of e to the c plus 1, which I will call C2. So this is going to give us 1 plus y prime is equal to C2. And I'll actually write down this step. We'll call e to the c1 equal to c2, because that would still be a constant. You raise a constant to a constant, and you still have a constant. So this is going to give us 1 plus y prime is equal to c2 over y minus 1. All right. So now we'll note that y prime is simply the derivative of y with respect to x. All right, so now let's rewrite this again. I'm going to keep this y prime on the left-hand side, but I'm going to call it dy dx. So we have dy dx is equal to C2 over y minus 1, and I'll bring this 1 to the other side in this form. We will call this y minus 1 over y minus 1 to simply give us, and well, actually, hold on. And now I'm going to call a new constant C3. We're going to let that equal C2 plus 1. So we can bring this C2 minus a minus 1 together into just one constant. All right, so that will give us negative y over y minus 1. But this is actually C2 plus C3. So yeah, this is still going to be a plus C3. And then I'm going to remove that negative sign and make this a1 minus y. No, you know what? I'm going to keep it like that. Negative y minus 1. Okay. Well, no. I don't want that negative sign there, so I'm going to make that a 1 minus y. All right. So I'm just going to rewrite this without that middleman there. So we have dy dx being equal to y plus c3 over 1 minus y. Okay. Now we're going to divide both sides by the right hand side and multiply both sides by dx. So that will give us 1 minus y over y plus c3 times dy is equal to dx. All right. Now we'll split this up into two separate integrals. So we will now have the integral. Well, actually, what we'll do first is just integrate both of these sides. So if this was true without the integral sign, then it's true with it. Okay, so now we're going to split this part up into two separate integrals. So that's going to be the integral of y plus c3 dy minus the integral of y over y plus c3. But, you know, we'll do it step by step. So that's still true. So that's dy, and this is going to be equal to x plus, we'll call this one c4. Okay. Now for this integral, what I'm going to do is I'm going to add c3 and subtract c3. So now I'm going to evaluate this integral in the next step. So this will give us the natural log of y plus c3 minus, well, splitting this up into two separate integrals, this one over this minus this over this. This will give us minus y. And then plus the integral of c3 over y plus c3. In other words, c3 times the natural log of y plus c3. And that's equal to x plus c4. Now we'll call c3 equal to a and c4 equal to b. We'll add these two together and factor out a natural log of y plus c3 to give us this. We'll get 1 plus c3, which is a, times the natural log of y plus c3, which is a. So we've taken care of that, and we've taken care of that. So now we have minus y. And in fact, I'm going to let b equal negative c4. So we can bring this c4 on the other side and add it as a constant b, and that will be equal to x. All right, and if you watch his video, which I will try to remember to link to, it is in a much different form than this, but they are equivalent. Both forms are true. Both forms satisfy y double prime times 1 minus y is equal to y prime times 1 plus y prime. So there you go. That's something a little bit different for this channel, but I hope you enjoyed it anyway.